Hi everyone. I realize I'm the only thing standing between you and lunch, but thank you for coming to the talk. My name is Helge. I'm from Officen. I'm a data scientist there, which means I work on all the data-related and data science-related things. I actually did my master's degree in machine learning at Stellenbosch University about 10 years ago, when machine learning was still a bit of a blip on the radar. I then got a job as a software developer. I was involved in building the initial version of SnapScan, a few other things that didn't turn out as well. But when data science kind of came back into fashion and there was actually people willing to pay you for doing it, I kind of pivoted my career back into data science type of things, and now doing that at Officen. So I just wanted to start by saying a little bit more about Officen and what our mission really is. So Officen was actually started after our founders spent some time in Silicon Valley, and they realized that this is sort of where the future is being built. The technologies that are basically driving our lives today are happening right here. Your Uber, your Amazon, well, maybe not Amazon, Silicon Valley, but Facebook, all of those. And what they also realized is that the people working on those things aren't particularly brilliant or better than us, but they just have more opportunity. So opportunity is, talent is basically equally distributed in the world. However, opportunity is not. And our mission is to do something about that. And we believe that the best way to do that is through software. Why? Because software is very much a meritocracy, and it's permissionless. You don't need a specific degree or anything to start building great software that people use and love. All you need is really a laptop, your internet connection, and you're good to go. Cool, so how do we do that? Well, in a couple of different ways. The one we're possibly most familiar with, you guys are probably most familiar with, is that we help devs get awesome jobs. A lot of people are stuck in jobs they don't really enjoy because they don't really know that there's other opportunities out there. So that's Officen. We also have Root. Now, Root is an insurance and banking API. So we like to say it's a programmable bank account. And it's a tool that's built to make developers' lives easier. Right? So it takes away all the complexity of banking and insurance and those things and let developers develop software, which is what they're good at, which is what they want to be doing. So an example of an app that was built there is basically an application where if you buy something like a Coke, or it will round whatever amount. So if the Coke was 8 Rand, it will round that up to the nearest 10 Rand. It will put the 2 Rand difference in your savings account. So every time you buy something, you're saving. So I think that was pretty cool, but there's also a lot of other things being built there. So that's about building like the tools that empower developers. Then we have Source, which is about helping devs learn faster and better. So Source is, you can go to the Officen website, you'll find the link there, and it's community content, so it's articles that the developers in the community are writing. And if you also want to contribute there, you're welcome to do that. You get help from our designers and from our editors to write the most awesome content you can, and you can publish yourself and share what you know with the rest of the community. And finally, we have a Make. So some of you might have been to Make Days before. So Make Day was really a day where you stepped out of your usual working environment and you would go to the Make space where you would play with new technologies, such as augmented reality or the Internet of Things or machine learning and those type of things. So Make has actually changed their mission a little bit. Right now they're focusing more on freelancing, and building that up, but we're hoping to continue with the Make Days, at least as a community type of mission. Cool, so that's a bit about OfficeN. Now, to get to the data science. So, like I think was said during the awesome keynote, like we had this morning, is that the modern developer and the role of the modern developer is changing quite rapidly, right? And a lot of that is driven by the new technologies that are available with through machine learning and through data science. So we see more and more that becoming like a powerful tool for developers to use. At the same time, like just by a show of hands, how many in here have either used machine learning or AI or quantum computing for that part in their product? So there's a couple of hands, but majority of developers still haven't done that. And we actually went and spoke to a lot of companies. We spoke to the developers working there. And also we looked at the actual data, being data scientists and having access to a lot of data of the sort of the tech work market in South Africa. And we found there's about 100,000 people in South Africa that call themselves something to do with software developer. At the same time, there's about 1,000 that call themselves data scientists. So it seems like there's a big gap between the tech talent we have on the software development side versus the skills that we need in data science. So we thought, what can we do about this? And our answer is basically, let's try and get more software developers doing more data science and more machine learning. Let's give them the tools and knowledge to enable them to do that. So that's essentially what this talk today is all about. Cool. So I'm first going to say something about why developers should do data science. Then touching, so that's the why. So then getting more about to the what, like what do you actually build? And then finally, how do you actually do it? And I'm going to show you a bit of a live demo of how we can do that. Cool. So why do we think it's a good idea that developers do data science? Or that one? So, the one we already touched on already, right? It's the existing skills gap. There's a lot of demand for solutions involving data science, machine learning, AI. We don't have a lot of skills around it. Let's use talent pool in the developer community to rectify that. The other reason is that the software developers are already trusted, knowledgeable tech people in their companies. Increasingly more so as software is eating the world. Companies are becoming more and more digital. It's no longer the developers are the back office running the tech, right? It's becoming more and more central and important in their companies. And finally, they already know the data as well as the product really well. Usually they are the people who wrote the code that generates the data, and they know very well how their product works. So those are three key reasons why we think that developers doing data science is a workable thing. Cool. So the question I get a lot, like what from the developers that I talk to when I make this pitch, ask me about what do we actually build. Like we're not Netflix, or we're not Facebook, we're not Amazon. We don't have tons and tons of data, rooms full of PhDs, all those resources that those companies have, and we don't have the need for recommender systems and all those things that they do. So I'm gonna take you through just a few principles with the angle that what is this technology really good at? What kind of problems is it quite good at solving? And the first one is, let's call it identification. So this is the the problem like you have a thing and you want to know what the thing is. It's the classic example, like, is it a cat or is it a dog, right? And what makes, or is it a hot dog or not a hot dog? If anybody's watched the show Silicon Valley, you might recognize this example. And so what makes this problem quite hard is that you never really know how the input is going to look, right? So anybody can look at that and say, hey, this is a hot dog, or that's not a hot dog. But to tell a computer to do that is really, really hard. Like, how would you do that with if, else, for loops? No, it's not going to work, right? So that's the first thing that machine learning is really good at, and it's because instead of telling the machine what to do, obviously, we give it examples. So we give it examples of these are hot dogs, these are other things. It will learn then to distinguish by itself which one is which. Okay. Then there's, before we go further, just to take it back to Office and what kind of problems do we have that involve this? And one of the that we have is if you upload your CV, like we need to recognize this is your education section, this is your working experience, this is your name, this is your but all CVs look different, they're structured differently, and the problem becomes, and this is a hard problem to identify, like this is education, this was University of Johannesburg, this was the year, so on. So we need to identify all those fields. The other kind of class of data science problem I think is interesting is called prioritization. Okay, or how relevant is this thing? So usually the problem here is you have a lot of stuff. You are Netflix and you have hundreds of thousands or millions of movies. Now you want to recommend or suggest to the user a few movies for that person to watch. And which one do you pick, right, from your millions? That's quite a hard problem to do. And an example again at Office N, like we have all these candidates, and whenever a company logs in and want to look for candidates to hire, at any given time there will be like hundreds of candidates on the platform, and they're not going to bother going through all of them. So we want to present them with like the most relevant candidates to you right now based on what you're looking for. So if you're looking for a senior Java developer based in Joburg, you prefer people from certain universities and things, then we want to show you those people first, the most relevant results. And the final class of problems that I think data science solves really well is this thing called like a needle in a haystack, or is this thing important? So the typical applications you find there is things like fraud detection or trust and safety on say, social platforms. So if somebody makes a video of themselves shooting up a mosque, you want to be able to detect that immediately and do something about it. But your problem you're facing is that 99.9% of your content is already is okay. So how do you find those very few cases where there's actually a problem? And as we shall see, this is also something that we can solve. So in our case, most people on the platform are quite well behaved, and they do what they do, and they're polite and everything. But now and then you get somebody who is not very happy about getting rejected from a job or whatever the case may be, and they might express themselves in unfortunate ways. So in that case, we want to detect that as quickly as possible and deal with it right there and then. Okay. All this data, by the way, is from our test systems. If you're on Office and you're not going to see your profile or anything popping up here. This is just test data. Cool. I then get to the part where I talk about how do you do this. So I find a very good way to think about it is this thing of data products. So what are you actually shipping at the end of the day? What is the tool that you're shipping, or what is the awesome new product feature that you're trying to create using the data, right? And a lot of the times when we have new technologies, we try to find some place to jam it in. Like, if I speak to a lot of people, their biggest problem seems to be like, what do I use machine learning for? And that's not really the right way to think about it. The better way to think about it is like, what is this technology really good at, and what are the problems or opportunities in our company that it can actually address? A very good book that has nothing to do with data science or anything, I just thought I'd bring it up, is called Inspired. So how to create tech products customers love. And it really talks about how to get out of this feature factory type of thinking, where you just, we want to build something because we can, to we build it because it really improves the user experience dramatically, or it solves very important problems. So definitely check that out if you can. Cool, so we can maybe think of data science applications as being two separate things. So the one is, and often when people say data science, this is what they mean, but it is about discovering insights, right? So this is your reports and your dashboards, and it's trying to understand what are the trends, what are the things that are happening. But the other side of that is the development of data products. So maybe this is the part that is more interesting to software engineers, and that is the stuff like the recommendation engines, of finding people on social media and all those type of applications. So that's not about using the data to understand what's happening or to interrogate, but it's actually feeding the data back into the product itself and driving great product features from it. Cool. So I'm actually going to show you a demo now of such a data product, what I mean by it, and hopefully that will help clarify a lot of the things around it. So what we're going to do, okay, so this is the LinkedIn. It's the profile of Linus Torvalds. Okay, and on his LinkedIn profile, he's got listed a lot of his skills. Okay, and then we're going to go to this side. It's called Indeed. Indeed is a job board. It's got a lot of jobs. You can search for jobs. So you can search for software developer jobs in Johannesburg, and it will give you hundreds of results of that. So what we're going to try and build is a product that takes the jobs from Indeed and Linus's profile and try and find the best jobs for Linus. And the way we're going to do that is actually quite simple. We're going to use a technique called the Jaccard similarity. Okay, so this takes, think of it as A being Linus's skills, okay, and B being the skills that are mentioned in the job ad. So if the job ad says Linux, and Linus's LinkedIn profile says Linux skill, then that's a match. So that's an intersection of those skills. Yeah, so we were just getting into the demo. So, cool, so this is Linus's LinkedIn profile. And if we scroll down, we'll get to his skills section. And here you'll see stuff that he's skilled in, like Git, Java even, embedded Linux, C. Cool, so that's what he's good at. And let's see here. These are the jobs for Cape Town in this case, but doesn't matter. And you'll see like these jobs will have specific skills that they're looking for. So then what we're going to do is to get our skills out of there, get Linus's skills, and find the best jobs for him. based on the skills, right? And then we use that Jaccard distance to find the most appropriate jobs. So what I've done is to go and scrape Indeed as well as LinkedIn. You can use any of the web scraping tools. So this is an important point. Like a lot of the time, even if you don't have the data you need to build the thing you want to build yourself, there's a lot of publicly available data that you can actually get your hands on and build really cool things. Cool. So the other thing we're going to need is, like you see, there's a lot of text in these job descriptions. Not all of it is like skills that you're interested in. So we need a way to get those skills out. And at least one way to do that is to have like a list of skills that are actual skills. So again, we turn to LinkedIn. So LinkedIn actually has a directory of all the skills that it has on its platform that you can have. So again, we can go and scrape those, which I've done, and put them into a text file that looks something like this, which is just a lot of stuff. But you'll find, things like Linux and Java probably in there. And then we look for those in the job description, and wherever we find then the match, we extract that as a skill that's relevant to that job. Cool. So I've done all of that and pulled it into a database. So it's quite a simple SQLite database. So there's one table with jobs, and another one with our users, which is just one, which is Linus at this stage. And here's his skills neatly sitting, in a field in the database. That's what he can do. And then we have our jobs, of which there are in total almost 1,000. Okay, and these are the descriptions of the job. So that's all the text, and there's also links to the job ads themselves in here. And based on that, let's see if we can find. Okay, so this is just the implementation of the Jaccard similarity. It's like, I think it makes it a little bit bigger. It's like super simple. You can probably do that in whatever programming language. Just find the intersection of two lists in this case. So this is in Python, and the union of them, and then you return the one divided by the other. So there's like 3 simple lines of code, and you got that. So this is what you would probably replace if you want to have more advanced models using machine learning and all those things. You might want to put more weight on the job title or certain skills, like something like software developer is a very generic thing. Specific things like specific languages, Java and so on, is probably should weigh them more. So this is where you would do that. And then I just embedded this in a very simple web app. So using the Flask framework, which is a lightweight web framework in Python. Just connecting to the DB. I'll show you, this is where we keep the scores. So that will always be a number between 0 and 1. Like 0 means that there was no overlap in skills, while 1 would mean that there was basically a perfect overlap in skills, and all the skills that were mentioned in the job ad, Linus has them, and vice versa. All the skills that Linus has was in the job ad. That would be like a 1.0, like perfect match. Okay, and then you have everything in between. So that's these scores. You see the numbers are quite low because the number of skills in a job ad is quite high. Like there's a lot of things in there. So that will tend to drive those numbers quite low. But what my app is doing is then getting the best matches and ranking those first towards the last matches. So this is the app. This is our data product, right? So Linus will log in, and he'll see this. It's called Linked. It's got about 1,000 jobs for him, and the top ones should be the most relevant. Let's just have a look. So the first one is a senior software engineer, so that looks quite relevant. Cool. Let's look at the next one. It's embedded software engineer. It does mention things like C and C++, which he did experience with, right? Okay, and the third one is a PHP developer. Okay, so when I first saw that, I thought that's quite funny. But it does actually mention both required Git skills and Linux skills, both of which software that he actually wrote himself. So, but this is where I'm saying maybe we should put more weight on what is mentioned in the job title. So there's techniques that can allow you to do that. Let's look at some of the skills that he's. Okay, let's go to the bottom. So is the least relevant job for Linus is customer service consultant, which I think is actually a good thing that we put that last, because he's not exactly known for being too polite. So that's good. So I mean, this is a very simple product, but it sort of works. I'll talk more about how we can improve it just now. Cool. Okay, so that is actually just the beginning of the data science. So at that point is actually when we really take on our data science hat and start thinking about performance of this thing, like how well does it work. And two concepts that are very interesting to know in that case is called precision and recall. So precision is defined as the true positive rate over the true positives plus false positives. So basically what a high precision number would mean is that the results that we return, so the stuff that actually Linus sees, like a lot of those jobs are relevant to him. Okay. On the flip side of that, you have what's called recall. So that is all the jobs that would have been potentially interesting to him, like how many of those did we show him. And these two tie quite directly into how your product will be experienced by the users. Like in our recommendation case, if our precision is high, that's probably okay. Like he can only apply to that many jobs anyway. So if the first ones he sees is pretty spot on, then that's pretty good for this product. We don't necessarily worry that much about recall. In other products like or fraud detection, or if you're trying to find that needle in the haystack, then recall is very important. Because you can have, like, if you find 10 fraud cases and they're all real fraud cases, but you're missing 100 or 1,000 of them, that's not a very good system. And recall would help us measure that. So this is the same thing, a slightly different view. So this doesn't work so well, but like the circle is basically the selected element. So that's the results that we would actually show Linus. Okay, and precision would be like how many of those jobs were actually relevant to him, divided by the total number that we showed him. Okay, this is precision, and recall in that case, like of all the possible relevant jobs, like how many of those out of those did we show him? So that would be the relevant documents and the true positives over all of them, basically. So how do we know? And this is a problem that we faced with often. Like, how do we know which ones were good or not? So one way to do that is to actually ask for user feedback. So imagine we did that and we asked Linus to rate like the jobs that he saw from a scale from 1 to 5, from 0 to 5. And then, so that's basically what is shown in the top row there, where it says initial data. So that's the actual experience. Like that's what he said he would have rated them. And then the second line is what we predicted, like how our like matching score at the bottom there, right? And then we can start calculating these numbers. So we're going to say like anything from 3 to 5 is going to be like that was a good match, and anything below, so we're going to put that in green here, and anything below 3 was a bad match, so we're going to put that in red, and then we can look at which ones we get right. So here we have like Linus rated this one 5, so it's top. It's a great job for him. We predicted that it would be a 4.5. So that was a true positive, right? We did that correctly. Over here we said this job is going to be appropriate for him, but he actually rated it as 0, so that's a false positive. Then you also get true negatives, like stuff that wasn't relevant and we didn't show. That's a true negative, and then you also get obviously true positives, false negatives. Cool. So let's do some calculations on that. So if we just go and look at the accuracy, so accuracy basically overall how much do we get right, both positives and negatives. So in this case we had this one was correct, like we said. This is a good match, and it was a good match. So that one is a true positive. This one we got right. We said it was not a good match, and it wasn't. Okay. So if we count those, we find basically 1, 2, 3, and 4 here. So 4 of those that we got right out of the total 6. So we get a 67% accuracy. Okay, but now if we go and look at what is our precision on that, like what is the stuff that he actually saw, because he never saw the ones that we didn't recommend to him, right? Then we find we got this one right, and we got this one right, so that's 2, right? Out of all the 4 that we said is a good match. So that means our precision is only 50%. So half of the time he's going to see basically a bad recommendation, which might not be a great user experience. So that's something to think about. Our recall is like 100%. Like he only actually liked 2 of these jobs, and we predicted both of them right. So the recall is 100% in this case. So what we then want to do, so data science is like fundamentally a iterative type of work. So it's different from software engineering in the sense that in that case you would often you would build a feature, it would kind of work or not work, so the outcome would be quite binary. Maybe you'll fix some bugs sometimes, or optimize or make it more scalable. In data science we often iterate and try to improve our models and make them better all the time. So this is called the CRISP-DM, cross-industry standard process for data mining, which is quite a nice process for doing this loop. So you have, you usually start with business understanding, what is the problem we're trying to solve? Okay, we're trying to find the right people for the right jobs. Then we need to understand the data we're working with, how those skills works and things. Then we need to prepare that data, we need to clean it, we need to put all the uppercase characters, lowercase, we need to remove funny Unicode things and all that stuff over here. Then is the actual modeling, which in our case was very simple, just this Jaccard similarity, but this is where it can get quite complicated, so you can put in neural networks or decision trees or regression models and all those things. And then you actually evaluate those against each other, which one is performing better than the other one. So in our case, that is a very simple thing. It's probably not going to perform very well. So quite easily, when we start trying out different models, they're going to be performing better. And at some point, we say, okay, we're either happy we think it's good enough, we can put this into production, so we deploy it, or we go back to the beginning. But either way, if it's working, we probably want to continue and make it even better all the time. So that's just an important difference. Great. So I'm basically at my conclusion. We think that data science can help build more amazing software, which is what we're all about, and helping people do that. A lot of the most famous products that we use every day, Facebook, LinkedIn, Amazon, whatnot, they're all using like data science, machine learning throughout the product to make it a great user experience. But we don't think it's only for those companies. Like we think it's for all companies. Like I showed you a very simple example with not a lot of data, not very complicated, but potentially could be a useful thing. And of course, finally, we believe that developers are the right people to start implementing these things into their products wherever they are. So with that, let's do that. And yeah, happy to take any questions there might be on that topic. Cool. I actually had a good one during our fire drill, which was which tools do we use and things, or which languages do you program in? So a lot of this stuff is Python. It's just become the main sort of language for a lot of the data science things. Although there are other things like Weka, which is a Java-based thing, and one of the most popular frameworks is for doing a lot of the stuff is Spark, which is natively actually written in Scala. And you can actually get started in any language, I would think. But at some point, yeah, you probably want to be looking into Python, and especially frameworks like scikit-learn or TensorFlow from Google, and so on. Another question I often get is like, what resources can you go to learn more? So definitely recommend like the Coursera courses. There's a machine learning one, there's a deep learning one. Also, Udemy has very good courses, although it's a lot. I think the data science course is 20 hours of video, machine learning course is 50 hours of video, and then there's a deep learning that's 20 hours of video, and reinforcement learning, there's also like something like 20 hours of videos. So there's like hundreds of hours of videos. But if you find the time and feel inspired, you can go on through it. But the best way to start learning is really to start just playing with things and building things yourself. Cool. That's a question over here.
Do you have any specific methodologies to avoid bias in the data sets?
Well, avoiding it is generally a good thing. Yeah.
But it like creeps in everywhere, like upon reading.
Yeah, it's something you have to deal with.
Balances or things like that two different people need to look at the data set and do weights separately or things like that.
I think it's a lot to do with how you collect your data. I mean, it kind of starts, once you have the bias there, the bias will be there. So, like if you're doing loan applications, you will only have the data from the people that took out a loan and you actually gave the loan. You don't know how the people who you didn't give the loan to, how they would have, if they would have actually like paid it back or not, and things like that. So there are techniques to try and overcome it, and that's a lot of what reinforcement learning is really about, actually. Something called exploration, where you kind of randomly test, but not too randomly either, but you kind of explore the other part of your data, and you basically start collecting data on that. So a useful algorithm there is called multi-armed bandit. So you can imagine you're in a casino and there's these one-armed bandits, and some of them will pay out like 80% of the time, and some of them 10% of the time, but you don't know which ones they are. So you start trying them. but at some point you will start to get an idea which are the good machines and which are the bad ones. And like the factors there, like how long do you have to play this thing? Because you can either exploit the knowledge you have right now, or you can try and like gather more data and learn more. But I think it's an important thing to be sort of just aware of that those things are there. But if you don't have it, you kind of have to make effort to collect better data. That's kind of the answer. Cool.
How do you guard against your data being polluted? So, say you have a control system and somebody feeds it false data.
Well, so these methods are somewhat resilient to dirty and data, as long as you have pretty good like test sets. So usually what you'll do, you have your training sets, which is what you'll feed to your model to learn from. And then you have your test set, which is a set that you've kept like aside to evaluate your performance. And yeah, generally if that test set, whatever performance you're getting from that, that is usually then what you can expect. But if you're talking about more like adversarial attacks, where somebody, I know that has been like a topic in AI lately, where you have self-driving cars, and what if somebody can attack that and trick the machine into doing that. I know there's a lot of research on it. It's actually where these adversarial networks came from, where you actually train the model with like fake data, and you train it to distinguish between the two. But that's fairly advanced things, and we're only really getting there now. So up until now, it hasn't been a massive problem. But once the cars start driving themselves, a lot of the things are autonomous. Then obviously it's going to be an important one. Cool, thank you. All right. Seems to be any more questions. So thanks everyone for coming.